All right, here's one last physical shape that I'm going to measure and find the different properties of. So we've got here a wonderful hexagonal prism. So let's start by measuring um, all the way across from one corner to another corner is about 15 centimeters. And nicely enough, the height is about 15 and a half. I thought they were going to be the same. So not nicely enough, close enough to nicely enough. So here's our wonderful hexagon, and from one corner to the next corner is 15 centimeters. And then when we draw the um, sides, we get this is 15.5 centimeters. Okay, so it's a regular hexagon. And so if I cut the top up into six little congruent triangles, then I know that each of these degrees here has to add up to 360 altogether. So there's 60 degrees in each of them. And because it's regular, I also know that these all have to be 60 degrees. So that's really nice. We have a bunch of equilateral triangles right there. And so that would make one of the side lengths half of 15, 7.5 centimeters. Let's measure it and just see if that matches up. Okay, so far so good. 7.5 centimeters long, each of the edges. So if I want to find the surface area of this whole shape, I'm going to add up two triangles plus six rectangles. Each of the triangles I can find with our formula 1/2 AB sine C. So 1/2. Oops, I just lied. It's not two triangles, it's two hexagons. And each of the hexagons is made up of six triangles. So that was almost a terrible error. Let's try to fix that. Two hexagons. So I'm going to do two hexagons. That's why there's the two there. And then each of those hexagons is made up of six triangles. Each of those triangles is 1/2 times AB times sine C. So 1/2 times 7.5 times 7.5 times sine of 60 degrees. Plus then six rectangles. And the rectangles are each 7.5 wide and 15.5 tall. Okay, so almost made a mistake with just what shape we're talking about here. But the rest of it should be pretty straightforward. Just typing things in like so. I'm going to type it in all as one big long line into the calculator there. Beautiful. Then I get surface area 989.78 square centimeters, and we're done with that. The volume of this shape is going to be base times height. So we need to find the area of the base, multiply it by the height. So the base is just this chunk that we just calculated here, six triangles, and the height is the 15.5. And so again, I can type all that in. And I get a volume of 2265.20, and that's measured in centimeters cubed. So that wasn't too bad. I guess one other thing that we could find about this shape is a diagonal. So imagine I go from one top corner across and down to the other bottom corner. What's the length of the diagonal that goes from there all the way up to there? In other words, if I went, say, from this all the way down to that, What is the length of the diagonal? Well, we can think about that as part of a right triangle. And so that diagonal, we'll call it D, is part of a right triangle where the other sides are 15 and 15.5. So D squared, I'm just doing Pythagorean theorem. So 15 squared plus 15.5 squared is 465.25. Take the square root of that, and I get that the diagonal is about 21.57 centimeters. And I guess just because this has all gone pretty easily, one other thing I could find is the angle that diagonal makes. So we call this angle theta over here. And so if I wanted to find the angle theta, I could use tangent. The tangent of angle theta is 15.5 over 7.5, which means angle theta is the inverse tangent of that. So what does that come out to be? Comes out to be about 64-ish. Degrees. And then because I'm feeling a little extra, I guess this angle down here I can find by taking away from 180 degrees the 90-degree angle in the other one. And so I get that this has to be about 25.82 to match up with this one being 64.18. And there we go. That's about all that I can think of we would possibly want to calculate about this hexagonal prism. I guess I could tell you how many vertices, edges, and faces there are. Why don't we do that just to finish out for sake of completeness? The vertices is 12, 6 on top, 6 on bottom. The edges is 18, and the faces are 8. And remember that our vertices plus our faces is always 2 more than our edges. All right, there we go. Please comment, ask questions if there's anything that I can do to help. Thanks for watching.